Folks, welcome back folks. In today's video I will be talking about some of the basics of algebra, and I'm taking some of the questions from the exercise 1.10. All right, so let's look into some of the basics of algebra. I'm going to start with a very simple problem. The question is x minus 2 equal to 7. I wanted to solve for x, and what can I do? This term is in subtraction with the x, so this is going to move on the other side, going to become positive. X equal to 7 plus 2. The final answer is x equal to 9. All right, uh, if I were to ask you to do a similar question like this, so x plus 5 equal to 4, pause the video and try to do it yourself. Okay, welcome back. So hopefully you got your answer. Now let's do it together. So this is going to move on the other side. X equal to 4 minus 5. X value going to come out to be minus 1 for this one. And let's look into some more complicated problems. If the question is minus t upon 2 equal to 5, I wanted to find the value of t. So this 2 is going to move on the other side. Minus t equal to 5 times 2, and then minus t equal to 10. And now this dividing both sides by negative 1, because I wanted to find the value of t, not the negative t. So this t has to be isolated term. So 10 divided by minus 1 is minus 10 is the final answer for this question. Okay, now y minus 8 upon 3 equal to 4. I wanted to solve for y. So how can I solve for y? So first of all, whatever is on the bottom here, that's going to go on the other side. And then I'll write it as 4 times 3, y minus 8. Now y value will be, to find the value of y, I have to move this on the other side. 12 minus 8, y value will come out to be 4. Okay, now let's jump into some more complicated problems. The question is 3t plus 5 equal to minus 4. I wanted to solve for t. So this, first of all, I have to move it on the other side. So 3t equal to minus 4 minus 5 equal to minus 9. 3t dividing both sides by 3 now, and then the final answer will be minus 3. So heads up here. So what I want to tell you is, sometimes what students see is, they see the question like this: 5 plus 3t equal to minus 4. What they do is 5 plus 3 is 8t equal to minus 4. That's wrong. These are not the like terms. You cannot add these two terms. Okay, the only like terms get added. This has to go on the other side. Okay, so this will be 3t equal to minus 4 minus 5. That's how you have to do it. Now let's look into another question. 8y minus 5 equal to minus 2y. Now there are two y's. Again, I'll apply the concept of the like terms. So first of all, multiply these two and these two. Distributive law: 8y minus 40 equal to minus 2y. And now this 2 is going to go on this side, 2y, and the negative 40 is going to move to the right hand side. 8y plus 2y is equal to 40, which is equal to 10y equal to 40. Dividing both sides by 10, and the final answer for y is equal to 4. Boom, we got our answer for the given question. Okay, now let's look into another question, that is 5 minus 2y equal to minus 3. This is relatively easy, so I'll encourage you guys to pause the video and try and answer this one. All right, let's see what's the answer you guys got. So minus 2y equal to minus 3, minus 5, minus 2y equal to minus 8. Dividing both sides by negative 2, y value is equal to 4 is the correct answer. All right, now let's do some more complicated problems. So the question is 7 minus 3 times 1 minus 2p equal to 4 plus 2p. I wanted to solve for p in this question. So 7 minus 3 times 1 and 3 times 2. That's what I'm going to do. Apply the distributive law. Minus 3 and plus 6p. Why plus? Because negative and negative will become a positive. 4 plus 2p. Now I'm going to collect the like terms on either side of the equation. So I'm going to collect the p's on the left hand side, and then this constants on the right hand side. 6p minus 2p, because this is going to go on the other side, and this going to move on the other side. 4 minus 7, this 3 is going to move on the other side, plus 3, and then 6p minus 2p is 4p, and then 4 plus 3 is 7, minus 7, 4p equal to 0, dividing both sides by 4, and then final answer for p is 0, because 0 divided by anything, the final answer is 0. One thing I want to tell you, anything divided by 0 is not defined. The answer for this one, even if you're going to put it in calculator, that's going to give you not defined if the 0 is in the denominator. All right, now let's talk about a little more a different kind of a concept of the absolute values. So absolute symbols are represented with these two parallel lines, and the number is put inside. So if the number is like this, minus x, so the final answer for this one will be x. And for example, if the number is negative 11, the final answer for this one is 11. And if the number inside is positive, it will still be positive. So what I mean to say is, whatever the number inside the absolute expression is, when you drop the absolute expression, it becomes a positive number. Now, based on this, we're going to take a simple example. So for example, mod of x minus 9 is 2. I wanted to solve for x. What are the different values of x can be for which this equation is correct? That's the whole idea of solving for x is. So now I will drop the absolute symbol. So this is going to become plus minus, because inside it can be a plus, it can be a minus. I wanted to solve for all the values, whatever it can be. And then this is going to go on the other side, 2 plus 9, which is 11. So plus minus x. So these two symbols going to go on the other side. X value can be plus minus 11. So let's do some check. So if I would have had 11 positive minus 9 equal to 2, 11 positive, let me change it so that you can see what's going on clearly. So it's like this. If I drop the absolute symbols, it's going to become 11 minus 9, which is equal to 2. So 2 equal to 2. If it was a negative, still when I drop the sign, it would have been a positive. That's why I got this plus minus here. Okay. So hopefully you were able to understand these simple basic algebraic questions. I'm going to take a couple of questions from exercise 1.11 also. I'm going to cover that in this, where some of the formulas, tricky formulas are given, and we have to solve for those tricky formulas. So for example, you're given an expression f equal to f upon d minus f. So basically it's the same algebra which we just learned, now in terms of variables or ABCD alphabets. So I wanted to solve for d. Solve for d. How can I do that? This whole thing's going to move on the other side. F times d minus f equal to f. Now I'm going to multiply this f with this and this f with this. So if I'm writing this f symbol is different from this f symbol, but these two are same, so they are like terms, these two. But this is not. One thing I wanted to give you a heads up here. A lot of students I've seen in past while teaching, they do this. That's wrong again. Okay, so please don't do that. So now let's focus on this question. So fd and minus ff equal to f. Now I wanted to solve for d, so this whole term is going to remain on one side, the rest of the term is going to go on the other side. Ft equal to f plus ff. And now I wanted to solve for d, dividing both sides by f. Dividing both sides by f cancels out. D value is f plus ff. Whoops, this has to be small f times f upon f. Okay, and again, please do not, this is the final answer. First of all, please do not start doing this. That's wrong again. Okay, I've seen a lot of students, what they do is 5 plus 3 divided by 5, they will do this, and that's wrong. You cannot do it. These are one term, you cannot just cancel them out. Okay, if something is in common between the terms, then you can. What do I mean by that? If it is like this, x plus, or let's say 3 plus y dividing by both sides by 5. Now this 5 belongs to all the terms on the top. So you can cancel this. But otherwise, if it was like the previous one, you cannot cancel that. So hopefully you're able to understand what I'm trying to tell you here. And I'm trying to tell you also where generally students make mistakes so that you don't make those mistakes while doing all these questions. So yeah, pretty much it for what I wanted to tell you. If I have to take one more question, so V equal to capital V M plus capital M divided by M. I wanted to solve for capital M. So again, I want to isolate this term. So this is going to go on the other side. V times M equal to, this is a different type of V times M, and then this is going to go with the capital M also. So Vm. Now I'm going to move this on this side, Vm minus Vm. This V is different from this, so I cannot mark it as 0. Vm. And now dividing both sides by capital V, final value for M is small vm minus capital Vm divided by small m. So that's the final answer. So hopefully you were able to understand these questions. So I'll highly encourage you guys to do questions from page number 50, but I will say from exercise 1.11, question 17 to question number 34. At least try and do these questions, and I will post some questions on D2L also. So try and do this. Again, the book which I'm using is Pierce, not the Pearson, it's a Washington book, 11th edition. So I'm referring to that book. All right. So I'll see you with another video. Till then, goodbye.